Okay. Morning. We are going to do some of these work problems from today. So you can use this to help you, excuse me, solve the problems. All right. Number one, if you push a car with a 500 newtons for 10 seconds, but it doesn't move, how much work have you done on the car? All right, the formula for work is force times distance. So if the car isn't moving, then are you doing work? Okay. Sierra playing basketball. We're giving her force, we're giving her distance, how much work was done by the jetpack. That's simple, just plug and chug. All right, let's look at three. We'll do three together. So Johnny pushes a 3 kilogram box across the floor with a force of 8 newtons, and the floor produces a force of friction of 3 newtons, and we know the distance the box moves. So we are going to solve for everything that it asks for. So here we go. All right, so how much work did Johnny do? All right. There we go. So work is force times distance, or in this case, it's going to be 8 times 10, and we're going to get 80 joules. All right. Friction is the same thing. For the work of friction, it's force times distance. In this case, the force of friction is 3. And it is moved for 10 meters, and that gets us 30 joules. Okay. Well, the net work is the sum of all of the works put together. So work would be 80 and then plus or minus 30. So let's think of it. Work is a vector, which means we have direction. We know friction always works against the motion of the object. So if Johnny's pushing it one way, friction has to work against it. Since they're going in 2 different directions, to signify that, we make one direction positive and one negative. It doesn't really matter. We'll just do 80 minus 30, which gives you a net work of 50 joules. Okay, and then find the acceleration. We can use either one of these formulas. It's actually a lot easier to use the one on the right. We can just use this via Newton's second law. So to find the acceleration, it's F. Well, we want to know the net force. Well, the net force would be 8 minus 3, which is 5, over the mass 3, 1.67 meters per second squared. Okay. All right. 4. So Carly lifts a 60 kilogram crate at a constant velocity, a vertical force. What force does Carly apply to it? So she's basically applying any force she wants to. The force she's trying to beat or overcome is the force of gravity. Children. So the force of gravity pulls down. And then pulling up is the applied force that Carly applies. And we know it's a constant velocity. So if it's a constant velocity, that means the forces have to be the same because the net force has to be 0 because you're not accelerating. So we know that FA equals FG. And we know FG is mg. So how much work, and this should not say Anaya because the problem is not about Anaya, it's about Carly here. Sorry, can't read. So to do this one, so we would find out how much work. So work, all right, is force times distance, but instead of using force, we know it's FA, we can plug in mg. So mg instead of force, distance. So work, okay, the mass 60, gravity 9.8, distance 10, and you get, oh my goodness, 5,880 joules. All right, 5 is really just the first problem. We're going to plug it right into this formula at the top. So we'll skip over how to do 5. Okay. 6. I think 6 is the toughest problem on the paper. So let's look at 6. So due to friction, a force of 400 newtons is needed to drag a wooden crate across the floor. The rope is tied to the crate and held at an angle 56 degrees to the horizontal. So first we actually have to find tension. And then from tension, we can find out what's the work being done on the box or the network. So this one, we definitely want to kind of draw a picture for. It's going to make life a lot easier. So here's our box. I'm going to say this is friction. So that's 400. All right, and we are pulling it this way to the right, up and to the right. All right, that's our applied force, or in this case, tension. Right. So we want to know what this value is. Well, it's not 400, and here's why. This tension is in the X and Y axis. In order to get this to at least move to the right, even if it moves with a constant velocity, the minimum value that the tension has to have in the horizontal direction is 400. Okay. But we're not pulling it horizontally or parallel to the ground. We're pulling it at some angle 56 degrees. So it really just becomes a trigonometry problem. So we have a right triangle. We know this is 400. This is 56 degrees. And if we look, this is the hypotenuse. This is the adjacent. So what trig function uses adjacent hypotenuse? That would be cosine. So we can say cosine of 56 degrees. It's adjacent over hypotenuse, or 400 over h. Remember, we can trade places, the h and the cosine 56, because they're on opposite sides, and the h is in the denominator of a fraction. So h equals 400. And to save myself and you guys my horrible handwriting, the cosine of 56 is 0.559. We'll go 0.56. And we divide 400 by that number. We get 714. So we applied a force of 714 newtons at a minimum to get the crate to begin to move. Okay. For B, how much network is being done if it moves at a constant velocity? All right, so this is a concept problem. It's not a math problem. If it's a constant velocity, then A is 0. If A is 0, then F is 0. And if F is 0, then work is 0. So what's the answer? 0. All right. Okay. 7, I'll help you out with the setup, but then I'll let you guys solve the rest of it on your own. So we have a crate, okay? And we know we're dragging this across the ground to the right. That's Eleanor, in case you couldn't hear her. All right, so that's you, FA, and we know the value of this, it's 220. Okay, and then friction is this way. Okay, so let's think this through. We're trying to find net work. So work net equals the work of FA minus the work done by the force of friction. Well, both of these are going to turn into force times distance. So we know the force, that's the applied force, that's 220, and we know its distance, 15, okay? To find the work of friction, we need to know the force of friction and distance, but we know the distance is 5.8, and to find the force of friction, right here, mu mg. We have mu, we have m, we have g, Once you find your two forces, you can plug it in and solve for work net. All right. So that is that. If you have any other questions, shoot me a remind and I'll get back to you. I'll post the key for this at some point tomorrow, and then we'll move on from there. All right, this is the end. We're going to do work, power, energy. So we have work. Tomorrow we'll look at power, and then we'll look at conservation, energy, and energy next week. And the other part is momentum. And then after that, that's the end. All right, we will be not, what was it? Time to go somewhere. All right, so guys, have a great time. Stay safe. Hope you're staying sane. That's all of you. Later.